something just happened near 3I/Atlas that scientists didn't have language for. A sudden, razor-clean burst of water vapor exploded off an object speeding through our solar system at over 60,000 miles per hour. And the moment NASA confirmed the signal wasn't noise, wasn't a glitch, wasn't a sensor echo, the room went silent. We've seen comets erupt before. We've even seen interstellar objects behave strangely. But this wasn't a cometary vent. It wasn't a thermal fracture. It was a directional blast, a controlled release, almost like a maneuver. And what came next pushed the discovery from strange to impossible. By the time the Deep Space Network recalibrated, the readings sharpened into a pattern. The water vapor wasn't dispersing randomly the way it should in a vacuum. It spread in a tight geometric cone, as if funneled through a structure we couldn't see. Something shaped the eruption. Something guided it. And for the first time since the first interstellar object, Oumuamua, slipped past us in 2017, scientists at NASA, MIT, Harvard, and the European Southern Observatory found themselves staring at the same question. Did we just witness a natural cosmic event we don't understand, or a maneuver from something not naturally formed at all? Right now, as you hear this, the object known as 3I/Atlas is already slipping away from Earth on a trajectory we'll never be able to chase again. That's why every observatory capable of pointing into that shrinking region of sky is pushing itself to the limit, because the window to understand what erupted is closing by the hour. If this was a natural event, we need to know why it behaved like an engineered one. And if it wasn't natural, we may have missed our best chance to see the first intentional interstellar activity ever recorded. But before we get to what scientists believe the eruption might mean, there's a detail almost no one noticed, a piece of data that wasn't published in NASA's public releases. Something faint, something orbiting. And this is where the story breaks from curiosity into something much heavier. The directional blast wasn't the only anomaly detected. A repeating signal, a tiny oscillation in brightness, appears to encircle 3I/Atlas at a rhythm too clean to be random. On the surface, it could be natural debris, a loose fragment trapped in a temporary gravitational dance. But when analysts ran orbital models at Harvard's Center for Astrophysics, something didn't add up. Natural debris spirals, it decays, it wobbles. But this trace held its line. Orbit, dip. Orbit, dip. Repeating with a steadiness that no unstable fragment should maintain. That's where the dual explanation debate splits the scientific community in half. On one side, you have the natural explanation. Maybe 3I/Atlas is a type of volatile-rich interstellar body we've simply never encountered before. Maybe its composition includes pockets of supervolatiles that, when heated by sunlight, erupt violently through narrow channels, mimicking propulsion. Maybe the orbiting object is just a compact chunk of ejected material caught in a highly unusual resonance, a rare cosmic coincidence. Strange, but not impossible. But then there's the other explanation, the one SETI researchers and propulsion engineers whisper about in private channels. The blast behaved like a controlled burn. The resonance behaved like a station-keeping maneuver, and the orbiting object behaved like a bound module or a probe. Not drifting, not decaying, just holding its pattern. If this was a machine, or even a fractured segment of one, then the eruption wasn't an accident. It was a course correction, or something like it. Before you decide which explanation makes more sense, listen to what happened when JWST locked on to the last observable emission trail. The spectral signature showed something no interstellar comet has produced. The water vapor carried a trace of heavy isotopes that normally only appear when water has been mechanically processed, filtered, refined, or passed through an engineered environment. The odds of that appearing naturally? Not zero, but low enough that several scientists privately admitted that if this sample came from any object inside the solar system, they would have assumed it was artificial. But then again, this isn't the solar system. This is an object from somewhere we've never been, shaped by conditions we've never seen. So, was the isotopic anomaly an engineered clue, or just alien chemistry we don't understand yet? While those debates were happening, something else began bothering the team at MIT that modeled the burst dynamics: the timing. The eruption didn't happen at perihelion, where comets erupt from heat. It happened moments after Atlas crossed a solar wind boundary, a turbulent region where charged particles spiked. Something about its response seemed reactive, as if it was responding to the environment rather than passively suffering it. Natural bodies don't do that. Machines do.
But natural explanations also haven't been ruled out. Some scientists argue that if this interstellar object had a porous, sponge-like structure, solar wind compression could ignite trapped volatiles in a directional burst. Rare, yes. Exotic, yes. But possible. And the orbiting signal? Maybe just a shard with the perfect combination of mass, angle, and momentum to stay locked in a temporary orbit longer than expected. Unlikely, but still possible. This is where the curiosity loop tightens, because to decide which explanation makes more sense, we have to understand one detail NASA hasn't officially commented on. Right after the eruption, Atlas's spin rate changed, subtly but measurably. A natural eruption should randomize spin, but the spin didn't randomize. It stabilized, it smoothed, almost like a gyroscopic correction. That's not a behavior anyone predicted. And with each new data point, the question becomes more urgent. Is this a new class of interstellar object, or did something pass through our solar system using physics we're just starting to recognize? Right now, the biggest pressure point is time. Observational windows are collapsing. The object is dimming, drifting into the background noise of deep space. The European Southern Observatory has already warned they may lose tracking capability within weeks. JWST can't dedicate long-term time without sacrificing scheduled missions. And ground-based telescopes are fighting atmospheric limitations as the object sinks lower in the night sky. Every unanswered question may remain unanswered forever, unless a new anomaly appears before tracking is lost. But then, late in the last observing window, it did. A faint emission spike appeared. Not water vapor this time, but something like heat. A thermal flare, short-lived, low intensity, almost like a device cooling down after a burst of activity. Natural bodies cool gradually. This cooled fast. Whatever released that heat was structured, contained, purposeful. If the eruption was a maneuver, was the thermal flare the equivalent of shutdown? Was the object stabilizing after adjusting its course? Or was it something else entirely? Something breaking apart? The uncertainty is pushing scientists into a race they know they can't win. Because if 3IATLAS really executed a maneuver, it means it was capable of decision, reaction, purpose. And purpose is the one thing in astrophysics that changes the meaning of everything. But even if we assume the natural explanation, the implications are still enormous. A volatile-rich interstellar object with narrow jet-like vents would represent a completely new category of cosmic traveler, one that could teach us how planetary systems form in environments radically different from our own. It could tell us what chemistry thrives beyond our local bubble. It could reveal the diversity of worlds that eject material into interstellar space. Losing the chance to study that is like watching a door to another galaxy swing open for a second and then slam shut forever. That's why there's tension on both sides. Either this object was natural but unprecedented, or it wasn't natural at all. And both possibilities push scientists into the same emotional space: awe, confusion, and a quiet fear that we're witnessing something beyond our current scientific vocabulary. And this brings us to the deepest question, the one no agency is willing to put on record. If 3IATLAS did correct its trajectory, then where is it going now? No one can answer. Its path leads into empty interstellar black, with no star anywhere near its projected course for tens of thousands of years. So if it really changed direction, why? What was it avoiding? Or what was it heading toward? We may never know. The object is fading, signals are thinning, and the last anomaly could happen at any moment, or never again. But after seeing what erupted off its surface, after watching something orbit it with unnatural precision, after recording isotopes that shouldn't exist without processing, and after detecting a thermal flare that behaved like a machine cooling off after a burst of activity, scientists are left with one final question. Did we just witness an interstellar object behaving like a natural body with impossible properties, or a machine disguising itself as one? And if it was a machine, who or what was it avoiding when it fired that burst? What do you think?